275 haters. So let's try to read the problem. So winter is coming. During the contest, your first job is to design a standard heater with a fixed warm radius to warm all the houses. So let me explain. So we are having a heaters array, and we are also having a houses array. So the heaters will be in a line, and the house will also be in a line. We are going to check what is the minimum radius of the heaters that can cover all the houses. Let me make a drawing. So for example, we have, let me use another color. So we have such houses. So these are the houses. And there are also some heaters. Let me just use a line to represent the heaters. Yeah. So we are going to calculate what is the minimum radius for the heaters that can heat up all the houses. So for this heater, for example, this point, it can cover these two houses, and this heater also can cover those two houses. And similarly, for this heater, it can also cover two houses. So if the radius, for example, is 1, so we're gonna get a result of 1. So this is the minimum. But how can we solve this problem? Because this n, I mean the length of the houses and the length of the heater, would be a very big number. It is 2 times 10 to the power of 4. It means we cannot use brute force to solve the problem. We have to use some n log n time complexity to solve the problem. So in order to check all the heaters, in order to check what could the radius of the heaters can be to heat all the houses, we can just check if there are heaters. So for example, this is a line, and in the line there will be a lot of heaters. So I'm gonna draw a heater like this. So these are the heaters. It will be in a line, yeah. But in real life, it is separated. It will be sparsed in areas. But for our case, for simplicity, the heater will always be in a line. So for example, maybe this is 1, this is 4, and this is 7, 9, and this is 13 maybe. Now, if we have the heaters sorted like this, because if we are giving a heaters, we can always sort the array. It takes n log n time. Yeah. Now we are going to have some houses. So for example, if we have a house of 3, what are we gonna do? So the house 3 would be put it here normally. But how can we find it? We can use binary search to find it. It will be located in between 1 and 4. And then we're gonna check the minimum value. So we're gonna check the maximum value. Yeah. So the maximum of 4 minus 3, 3 minus 1, it is 2. Yeah. So if the radius is 2, if we are going to check the maximum value, because if the radius is 2, definitely this heater can cover on those two houses. Yeah. If the radius is 2. Yeah. But for example, if there is another one, yeah, let me try to use another one. For example, there is 8. So there are another heater. Yeah. So the heater will be here. Yeah. So in order to cover the two houses, so the heater will be like this. So what is the radius? So the radius is 1. But we're gonna check the maximum value. So the maximum value of 2 and 1 is gonna be 2. Yeah. So we consumed all the houses because we are going to hit all the houses. If there is another heater left behind, it didn't do anything. It doesn't matter because we want to hit the houses. It doesn't ask us to use all the heaters, so that is enough for us to solve the problem. Now we're gonna just return 2. If the radius is 2, this is gonna be the minimized. Yeah. If it is 1, some of the houses cannot be heated. So for example, the house is located at position 3. If it is 1, it can only hit another 4, but it cannot hit 1. So the radius must be 2. Yeah. Now let's try to solve the problem. If you understand the process, we're gonna first sort the heaters array, and then we're gonna check the house one by one. And if the length of the house is m, and the length of the heaters array is n, so the time complexity would be m times log n. That is why we can pass for the Leetcode. Now let's go back to the code editor to finish the coding. So as I said, I'm gonna sort the headers first. Yeah. So but I'm gonna prepare a result. I'm gonna prepare a result because it's gonna choose the maximum value, or the possible value. It's gonna choose the maximum. I'm gonna have a minus infinity, and then I'm gonna prepare the headers array. But here I will do some tricks. Normally I will do like that. I'm not sure what kind of tricks you're gonna do. Maybe you don't need to plus this infinity and plus another infinity. But for me, because I just need to use one line to check the bisect left, otherwise I have to check one by one. This is gonna be easier for me to check. Normally I will do it like this. Or you can just use the headers directly. You just need to sort it directly. So headers dot sort. Now we have the headers array. It is sorted. But for me, I give a minus infinity and positive infinity just to handle some edge cases for the binary search. Now I'm going to check the houses. So for H in houses, I'm going to use the bisect left. So bisect left with all the headers and with this house. Yeah. So for this index, normally I'm gonna use this index to check the result. Yeah, but I will have a temporary result. So the answers would be the result of the two. Yeah, let me put the first example. You can understand it. So for the first example, the headers would be minus infinity 2 and positive infinity. We're gonna use this headers too. Yeah. So after sorting, it will be like this. Yeah. Now we are going to check the first house. It is 1. So for 1, where is the index? So it will be index 1. So what is the result? So the result would be this 1 minus the previous value, and this 2 minus 1. It's gonna choose the maximum. It's gonna choose the maximum, I believe. Let me think. Yeah, let me first prepare the answers. So yeah, so the answers would be the it's gonna choose the minimum. Yeah, it's gonna choose the minimum. Yeah, so for this one, you know, this 2 and minus infinity, it's gonna choose the minimum because the house is 1. 1 minus infinity, it's gonna be a big value. 2 minus 1, it is 1. So for this one, it's gonna choose a result of 1. Yeah, I think I didn't explain the problem exactly like the algorithm here. Yeah, normally for the headers, it will be designed like this. Now, let me explain again. Now, here we have the headers, and if we have a house like this, yeah, this house didn't choose the maximum. The house would always choose the minimum. So for here, I didn't explain it right. I checked the maximum. Actually, it is not the maximum as you say. It should be the minimum, because for this house, I only need one header is enough for me to hit the house up. I don't need another house, so I'm gonna choose the minimum. Yeah, as you can see, if this is the house, and this is my house. Yeah, and this is the header. So of course I'm gonna choose this header. This is like what is in real life. So there are hidden components. This is company 1 and this is company 2 for you to choose. Yeah. Now you are at this location. Normally you're gonna choose the nearest. So the nearest place is here. We just choose the nearest. So this is why we're gonna choose the minimum of the two distance. Yeah. I didn't explain it right. Sorry for that. So it's gonna be the minimum of the position. So for example, if the house is 1, let me put a 1 here. So the index would be would be at index 1. Yeah, so it would be the minimum of headers array. So headers I minus 8 with 8 is 1 minus headers I minus 1. Yeah, because we used this infinity, negative infinity and positive infinity, so we just need to use one line to execute it. Otherwise, we have to check the different situations. We have to use the 3 line. I will explain that later, but let's just check this one line. It should always work. Yeah, so for example, if we are going to check house 3, yeah, now it's not 1, it is 3. So where is the index? So the index should be 0, 1, 2. The index should be 2. So the header is 2, this infinity minus 3, and 3 minus this 2. It should be a 1 because we're gonna always choose the minimum. But the final result would be the maximum because we're gonna hit all the houses. If we were to hit all the houses, we're gonna choose the maximum of the answers. So the answers and the result. Yeah. Finally, we can return the result. Now let me run it to check if it. Yeah, I did something wrong because this is the index. I used the index. It is not I. Yeah, as you can see, it works. Now let me submit it. Yeah. As you can see, it's pretty fast, and the time complexity is n log n or m log n, because the two arrays may be different lengths. The length of the headers, so after sorting the header, if the length of the headers is n, so it is n log n time. Yeah. But for here, n log n, here is m log n. So the time complexity is m plus n times log n. So this is for the time complexity. But m should be similar to n. So the time complexity basically it is n log n time. Yeah, because they have the same length for the maximum. Yeah, that is why it can pass. But if I don't use the negative infinity and positive infinity, you can check what I did before. This is a, yeah, I think I've already deleted maybe. Yeah, but if we didn't use this, we have to check a lot of things. We have to check if this index is equal to 0, or if this index is equal to n, or if this index is more than 0 and less than n. Yeah, it's gonna be I have to prepare 3 lines. I didn't prepare the result, but I think I can code it up if we don't use it. So it's gonna be really difficult to check. Yeah, if we don't use it, we have to check the conditions. So if the index is equal to 0, so the result would be equal to, yeah, since it is equal to 0, yeah, I have to use an example. So for example, I'm gonna use 2. So yeah, if it is equal to 0, for example, if the result, the house is 1, it is 0. Yeah, so I'm gonna use this index headers index minus 8. Yeah, I have to check another case, elif index equal to n. So this means I'm gonna check a 3. If it is a 3, so the index would be equal to 1. So 1 should be equal to length of the array. So it should be, yeah, it should be the house minus index minus 1. It will be like this. Yeah. Otherwise, answer would be like this. Yeah, as you can see, if we don't use that tricks, it's gonna be a lot of line. We have to check a lot of situations, and yeah, you're gonna yeah, here should be the answer, not result. Yeah, this n should be the length of the headers. Let me check. Yeah, length of the headers. Yeah, as you can see, it also works, but there's a lot to check. You have to check the different cases. So it always depends on you how you're gonna solve this problem. Yeah, but for me, if you use like this, it's gonna be really fast. You don't need to check every edge cases for the binary search. Normally I will do it like this. Yeah, I'm gonna prepare negative infinity and positive infinity at both ends, and I just needed to use one line to represent the result. Thank you for watching. See you next time.